So, today we're going to talk about a technology that has literally jumped from hobbyists' basements and workshops right into the heart of the modern operating room, 3D printing. We're going to explore how this incredible tool isn't just tweaking medicine around the edges, it's actually starting to make the impossible possible.
And you know, this quote really hits the nail on the head. For a long time, 3D printing was fascinating for sure, but to a lot of people it just felt like a cool gimmick, a party trick. But in medicine, it found its true calling, its high-impact application. It transformed from a curiosity into a truly critical, life-saving technology.
And this is exactly what we mean by high impact. I mean, just look at this thing. This isn't some plastic toy. It's a precise, one-to-one scale model of a real patient's pelvis, showing a cancerous tumor in perfect detail. By holding this in their hands, surgeons can see exactly how the tumor is wrapped around bones, nerves, and arteries before they ever even make an incision. This is a total game changer, slashing surgical time, boosting patient outcomes, and taking 3D printing way beyond a simple party trick.
So, to really get how we got here and where this is all going, we'll start with the basics of the technology itself. Then, we're going to step inside a hospital's print lab to see how it works day to day. We'll look at the tangible impacts it's having right now, then jump to the absolute frontier, printing living tissue. And finally, we'll have to confront the very real hurdles and the deep ethical questions this powerful technology brings up.
Okay, so let's rewind a bit and start at the beginning. What are we actually talking about when we say 3D printing in a hospital? Well, the official term for it is additive manufacturing.
The key concept to grab onto here is layer upon layer. You know, think about how things have been made for centuries. It's usually subtractive. You start with a big block of wood or metal, and you carve or mill away everything you don't need. Well, additive manufacturing is the complete opposite. You start with nothing, and you build an object from the ground up, one microscopic layer at a time, straight from a digital blueprint. And this gives it this incredible flexibility to create really complex, intricate shapes that would be almost impossible to make any other way.
And that flexibility has led to some absolutely explosive growth. Just think about this for a second. Back in 2010, you could probably count the number of hospitals with a serious 3D printing lab on one hand. Fast forward to 2022, and that number skyrockets to over 400. This is not a niche experiment anymore. It's quickly becoming a fundamental part of the infrastructure for advanced healthcare. So what does this actually look like on the ground? How does it all work in practice? Well, let's step inside one of these hospital labs. It's this amazing intersection of medicine, engineering, and pure data. Inside one of these labs, you're not just going to find one type of printer. Different jobs need different tools. So for a simple, functional model, a hospital might use FDM printing, which is pretty inexpensive. But for a super detailed anatomical model where every single millimeter matters, they're going to turn to something like SLA, which uses UV light to cure liquid resin and gives you incredible accuracy. It all comes down to picking the right tool for the specific clinical job. Now, what's really crucial to understand is that creating one of these models isn't just about someone hitting print. It's a highly collaborative process. It all starts with a surgeon who needs a better look at a complex case. Then, the radiology department takes that patient's CT or MRI scan and digitally isolates the exact anatomy they need, a heart, a tumor, a fractured bone, turning flat images into a 3D file. From there, biomedical engineers take that file, clean it up, and print the physical model. And finally, the whole team gets back together, surgeon and radiologist, to hold the model, study it, and map out the very best surgical plan. And all that detailed, collaborative work, it pays off in huge, tangible ways. This isn't just about making cool-looking models. It's about delivering better, faster, and safer care to patients.
I mean, the research is crystal clear on this. Using these models for pre-surgical planning has incredible benefits. Surgeries get shorter because the team has basically already rehearsed the most difficult parts. Surgeons can pinpoint tumors with way more precision. They walk into that operating room with more confidence, and all of that leads to fewer complications and ultimately better outcomes for the patient. You know, every minute saved in the OR is a massive win, both clinically and financially.
And we're moving beyond just models to look at. We're now printing actual tools. This is a brilliant example. A patient-specific surgical guide for dental implants. It's printed from a special biocompatible resin and fits perfectly over the patient's gums and teeth. Those little metal rings you see, they guide the drill perfectly, making sure the location, the angle, and the depth are exactly as planned. This brings a whole new level of robotic precision to these procedures.
Or check this out, another amazing application. When treating cancer with radiation, doctors sometimes use a material called a bolus to shape the radiation dose. The problem is, standard, flat sheets of this stuff don't fit well on complex areas like a person's nose, which leaves air gaps. But a 3D printed bolus, made from the patient's own scan, fits like a second skin. It's perfect. This means the radiation dose hits the tumor exactly where it needs to, while doing a much better job of protecting healthy tissue, like the brain, just underneath. It's the definition of personalized medicine.
Okay, so everything we've talked about so far is already revolutionary, right? Using plastics and resins and metals. But the true frontier, the next great leap forward, asks a much bigger, much more profound question.
This is where science fiction really starts to become science fact. I mean, the ability to print with the actual building blocks of life, it just opens up a universe of possibilities that could completely change how we treat disease and heal from injury.
And this is what we call bioprinting. So, instead of a spool of plastic or a vat of resin, the printer uses something called a bioink. Now, a bioink is this carefully designed mix of living cells, often stem cells, suspended in a kind of biocompatible gel or scaffold. Then, the printer lays down this mixture, layer by tiny layer, to build three-dimensional living tissues.
And if you're thinking, okay, this sounds like it's decades away, well, it's not just a theory. There have already been these unbelievable early successes. A bioprinted trachea, custom-made for an infant, was implanted to literally save their life. And get this, researchers have printed a bionic ear by weaving together cartilage cells and electronics, and it could actually detect frequencies beyond what a normal human ear can hear. The potential is just mind-bending.
But before we all get carried away planning to print ourselves a new kidney on demand, we need to take a serious reality check. The road from these amazing proof-of-concept experiments to everyday clinical use is filled with enormous technical, safety, and regulatory challenges.
And to be clear, these aren't small problems. How can you guarantee that a printed implant is accurate down to the micron every single time? How do you sterilize a really complex, porous printed object without damaging it? And how do regulatory agencies like the FDA even begin to approve devices that are manufactured right there in the hospital for one specific patient? And that's not even mentioning the practical safety issues, like handling potentially hazardous fumes from the printers. These are the tough, practical questions that have to be solved first.
And even if we solve all of those technical challenges, we run headfirst into an even deeper, more complicated set of questions. Because when we gain the power to print living tissue, we have to confront the profound ethical implications of what it actually means to create, to repair, and maybe even to enhance the human body itself.
Let's start with a basic question. Where do the cells come from? If we use what are called autologous stem cells, which means they come from your own body, it's ethically more straightforward. The main concern there is just patient safety. But if we use allogeneic cells, meaning they come from a donor, a whole new world of ethical issues opens up. Did that donor give fully informed consent? How do we protect their privacy? And what's to stop the commercialization of human cells? And this leads to what is probably the biggest societal fear of all. This technology is and will be incredibly expensive. This quote warns about a social stratification of biofabrication. Basically, a future where we have a two-tiered system of healthcare. A world where the wealthy can afford to buy custom-printed, rejection-proof organs, while everyone else is stuck on the same old transplant waiting lists. And that really brings us to our final and most critical question. The power of 3D printing in medicine is absolutely undeniable. It's already saving lives. It's pushing the boundaries of what we thought was possible. But as we build this incredible future, we might find that the biggest challenge isn't a technical one, but a human one. As we print the future of medicine, how do we make sure it's a future for everyone? That's the question we're left with. Thanks for tuning in.